right here. Now notice at standard states, this would be U3 plus 1 molar, U3 plus 1 molar, uranium, uranium. What would delta E0 be? At standard states, each side is exactly the same, so delta E0 is 0. Even though I gave you a cell potential for U going to U3 plus 3 electrons gives you U, you don't care, because for this cell it's going to be plus 1.80, let's say, and for the other one it's going to be minus 1.80. That's going to subtract and give you 0. And that's why I said in big letters concentration cell, because all that's varying is the concentration. Now what happens, you're going to say, is 0. Because at standard states, both half cells look the same. We'll get a little fancier in a few minutes to do the KSP problem. So that means the Nernst equation gives you what's the spontaneous reaction? There is going to be a cell potential. There's going to be something happening spontaneously. What's the spontaneous reaction?
It's 0.00659.
Things always spontaneously get more dilute. So it always goes from the concentrated to the dilute. What tells you that? Why? What's the driving force, as they say in chemistry sometimes? You go all the way back to thermodynamics and you say, for that change, delta S is always a positive number. There's more disorder in a dilute solution than there is in a concentrated solution. So things always go from more concentrated to more dilute. Actually, the probability is very high. You can't say it's always, but nobody in their lifetime has ever observed this going in the other direction. This isn't a closed system, by the way. If the water evaporates, of course, it's going to get more concentrated. But you never see all the solute molecules move to one corner of the bottle and sit there by themselves. They always diffuse throughout the whole thing. So that's what's always going to be true. And when you look at this, Q is always going to be less than 1. Because you're going to have the bigger number, the smaller number over the smaller number over the larger number, so it comes out to be a number less than 1. That means the log of that is a negative number. Less than 0. Less than 1 is the same thing. In other words, it means you get a negative number. Then a negative number and a negative number give you positive E cell. That's the spontaneous reaction. Did I erase my cell? Oh, there it is. So this one's easy. First of all, you look at it, you say, here's one of the reactions. That is the half cell reaction. What's the other half cell reaction? And you write for your thing. Well, 3 electrons, most common multiple, somebody said 3. Ln. I'm just writing this all out. Now, if you show me all this and write the correct answer, that's all you need to do. But I put these extra steps in here lots of times to see them with my solutions too, because sometimes students have numbers appearing out of nowhere, and I have to sort of see if I can recognize the number. So when I took the log of the 0.0165, whatever it was, I got minus 3.29. Notice 2 minus 3 plus. Okay. The problem becomes this problem. This was easy. As long as you look at those, you can always say which is bigger and which way that equation should go together. I don't have one of these, I don't think, on the quiz page. Well, I sort of do. What's the concentration of, what's the missing concentration? And you know right away there are 2 possible answers, right? I hate problems with 2 possible answers, so that means I didn't give you enough information for you to decide. I can say left electrode is the cathode, or I can say left electrode is the anode, I can say right electrode, whatever I want to say. Or I can say I followed the book's rules. If I said I followed the book's rules, what does that mean? That's the cathode. Okay. So let's follow the book's rules. Then you would write and I'll write the whole thing out the way I did just a minute ago and add it together. my reduction. The other one is U equals U3 plus, I'll use an X instead of a question mark, plus 3 electrons. And so we're going to solve this equation here. I said it was 0.0032 minus and we said it was a 3 electron change, Ln x over so some books when they give you this they'll say oxidation over reduction because it's the oxidation, that's the reduction. Other books will say dilute over concentrated. Their book doesn't say either. I guess he does say dilute over concentrated. But this is the problem we would do. And so now the way you solve this, by the way, because people always have trouble with this, I'm going to put it in 0.02569 because I don't want to put numbers into my calculator. So it's going to be E to the minus like that. So that's how you want to solve it because you know all the numbers, so you can take the anti-log. Let's see if I made up a good problem. The eye doctor keeps saying I don't need glasses anymore, but I can't read it. And it says X is, whoops, that's not X, 0.6 and 0.688. And then you cross multiply and get X. I would have said, what did I say? Book's rule. I could have said left electrode. Cathode. Okay, I say left electrode is the cathode, then you write and you can see just from what I did a few minutes ago, the reaction becomes and now your the expression says, notice the number stays. No, we don't. Let me write this out so we don't make a mistake. It says that 0.0022 is equal to minus RT over 3F Ln X. And now we have 0.688 is equal to because that part of the number stays the same when I cross multiply and everything, but now it's 0.688 equals 0.0025x, and you get a number slightly bigger than 0.0025. Yes?
What's the number on top of that RT? 0.0.
Let's see.
2569.
Where are we pointing?
On top of the RT?
To your right.
To your right? Yes,
Up.
right there. Yes.
Yeah, so in other words, remember Oh, right there,
Yeah.
yeah. That's R times T over F. And I said, lots of times when I'm solving these problems, I just put in RT and F, but it takes too long to enter it. So that's what a lot of people do, is they just remember this number because that's what RT over F is. Unless I tell you it's at 405K, then it's not that. But since I'm doing the same electrochemistry problems they do in the book, and people when they do electrochemistry don't usually change the temperatures, at least not in introductory chemistry. I've never seen an electrochemistry problem in a textbook for Chem 1AB where they changed the temperature when they were doing electrochemistry. Okay. So that's the concentration cell. I'll finish up the discussion in the other room, I guess. Oh, yeah, there's a class coming.